Okay, so this is a journey into music and sound with math, engineering, and Matlab, and this is part 4 of our series. Let's take a look at what we will explore in this part of our series. First, we'll take a look back at part 3 and just the key points that we went over in part 3 in terms of different ways to manipulate music. And then we will look at playing music fast and playing music slow. If you're from back in the 80s. You may remember, I think it's the 80s anyway, you may remember Alvin and the Chipmunks, and we associated playing music fast with those characters. And also, we'll look at playing music slow. And if you're familiar with more of the hip hop scene back in the, I guess it would be early 90s, mid 90s, DJ Screw. We'll look at how you would slow down music and what is called screwed music. Okay. All right. So let's take a look back first at what we did in part 3. And remember, in part 3, what we talked about was reversing music. And we said that music is stored in these structures called vectors. And you have column vectors and you have row vectors. And we said since in our program we are using column vectors, if we wanted to reverse the music, what we needed to do was to use the flip upside down function inside of Matlab in order to take our music, which was, let's say, in this order, the first sample, second sample, third sample, so on and so forth, till the last sample, use that function, putting the letter y in here, or the variable y, which is a vector. And then what that would do is it would reverse the vector so that the last sample is first and the first sample is last, and all others correspond to that order. Okay, so that's how we reverse the music. We then said that if we wanted to increase the volume or increase the loudness of the music, what we needed to do is to, of course, first recognize that the human ear does not hear in a linear scale. Okay, it hears more in a logarithmic scale. The way that we perceive loudness or an increase in volume is more within a logarithmic scale. So, for example, if we wanted to increase the sound uh, that is being played or music that's being played, what we needed to do instead of multiplying our samples by 2, actually what we needed to do was to multiply the intensity of each one of the samples by 10, okay, in order for us to be able to hear that difference, or what would sound like twice as loud. Okay, and this would mean an increase in 10 decibels, and you may have heard the term before, 10 decibels in music, okay, or sound. All right, so that's a review of part 3. That's what we looked over. If you're interested in that, definitely do go back and check that out. It is on YouTube. Okay, so now what we're doing is we're actually looking at speeding up sound and slowing sound down, the music down. And if you recall back in part 1 of the series, we talked about how we can represent a signal or music signal by modeling it in a discrete way. And what that means is that we go through and we sample and quantize the values. So if this is a sine wave, what we do is we sample at this time, we find out what the value is, this time find out what the value is, so on and so forth, until we get something here that looks sort of like a sine wave, okay? And we said that the time that's in between each one of these samples here is what's called a sample period. Okay. And if we take that sample period and we invert it, then we get what's called a sampling frequency. And we said that the sampling frequency for CD quality music is actually about 44 kilohertz or 44,100 hertz. Okay, that's the value. Okay, so if we wanted, let's say, to speed up the music or speed up the sound that's being played, what we can do is we can double the frequency of the music, and what that does is it causes the music to play faster. So in other words, we're saying we want to play the samples much quicker than they were before. Okay, so if we want to double it, we'll be playing it twice as fast. And what ends up happening is we no longer, if we were to double the sampling frequency, we no longer have CD quality, but however, we'd be able to speed the music up. And we can say that that speeding up, we can associate that with the Alvin and the Chipmunks from back in, I think it was the 80s. You can associate that with the music that you'd hear that they would play, if you will. Okay. And if we want to, let's say, slow the music down, what we do is we'd actually take the sampling frequency and divide that by 2. Okay, and by dividing it by 2, what we end up doing in that case then is we end up slowing the music down, and that's sort of what DJ Screw would do back in the day. And if you've ever heard Paul Wall music, he did some screw music back in the day. um, that's what you'd be hearing when they say the screw part of the chopped and screwed. Okay, so now that we have all that information and we have a better idea as to how we're going to speed up the music and slow down the music, what we're going to do is we're going to take a look at doing this now in Matlab. Okay, so let's move over now to Matlab. All right, so here we are in Matlab. And as you can see, I'm at that point here where I'm doubling the sampling frequency, and I'm telling Matlab to now play the sound of that. And then I'm going to store that into a file named Flyaway Chipmunk, and it's going to have a .wave extension. And then also down here, what you'll see is that I'm halving the sampling frequency, and then I'm going to play that sound with half the sample frequency. Okay, and that's what's stored inside the vector. And so that's going to end up playing the music slow. And then what I'm going to do is I'm going to write that into a file, a wave file, and I'm going to save it as flyaway screwed. Okay, so I've set a breakpoint here to stop the music, or to stop the file from reading the code that's here. So after the first time when it gets to here, at this point, line 67, when the green arrow shows up, what it's gonna start doing is playing this music here, and it's gonna just continue. Okay, and so we'll play that. Since it's half the speed that, or twice the speed, pardon me, it should finish relatively quickly. So we'll go ahead and play that, and you'll hear what the music sounds like now that we've doubled the sampling frequency. Okay, so that was that song "Fly Away" that we've been playing throughout the series here. And the reason why I'm using that song, by the way, is because it's open, no royalties whatsoever. That's why I chose that song. So, all right, as you can see here, these two files or figures came up from before, and these were just dealing with the original music and then what it would look like if it was increased. So you should remember those from before. Okay, so at this point now, what I'm going to do is I'm going to slow the music down, okay, by playing this section of the song here. And in order to do that, I'm just going to go ahead and tell it to continue, okay? And I'll probably just go through part of the song and then end at that point. So let me just make the closing remarks at this point. So this is a journey into music and sound with mathematics, engineering, and Matlab, and this is part 4 of the series. And again, what we were looking at in this part was how to speed up the music and how to slow it down. Okay, so I'll go ahead and just play probably about a minute or two of the song and then close it out from there.